In high school math, the monotonicity of functions has always been our challenge. For this question on the test, 90% of students got no points. Let's take a look. It states the function equals 1 over x in monotonically increasing intervals of, we need to find the increasing intervals. The question is simple, but the key is how to analyze it, right? Okay, this is clearly a composite function, right? But I need to tell you, before finding which functions are combined, you must do one thing first. What is it? First, find its domain. So what's its domain? It's where 4 plus 3x minus x squared is not equal to 0. So we get, let's calculate, that's x squared minus 3, x minus 4 not equal to 0. So we need to factor it, right? Multiply minus 4 by 1, cross multiply and add, which gives us exactly 3x in the middle. So it's x minus 4, x plus 1 not equal to 0. Remember, the cross multiplication method from middle school is factoring important, very important. So it has two roots, 4 and minus 1. Not equal to 0 means it can't equal 4 and it can't equal minus 1. So you need to use the AND relationship, right? Not equal to 4 and not equal to minus 1 is what we need. So x is not equal to 4 and x is not equal to minus 1. Therefore, we can say, what about this function's what? What is its domain? Since your monotonic intervals must be within the domain, they're a subset of the domain, right? So it equals from to minus 1, then union with minus 1 to 4, then union with another piece, which is 4 to plus. You can write the domain in set notation or interval notation. Either way works for its definition. We're excluding 4 and minus 1 from all real numbers. So our function is y equals 4 plus 3x, x2, 1. So what is it composed of? For composition, look at which is the outer function and which is the inner function. Which is the outer function? The inner function is u equals 4 plus 3x minus x squared, and the outer function is y equals 1 over u, right? That's very obvious. This outer function, no matter which interval it's in, it's always monotonically decreasing. There's no doubt about this because it's an inversely proportional function, right? The key is this inner function. What is it? It's a downward opening parabola, right? Its axis of symmetry is 2a divided by b. That's 2/3. Its axis of symmetry is 2/3. And it's a downward opening parabola. So from negative infinity to 2/3, it's monotonically increasing. From 2/3 to positive infinity, it's monotonically decreasing. That's how it works. So what we need is for the composition to be increasing. Does our composite function maintain monotonicity? What's the 4-character term for this? Same increase, opposite decrease. What does that mean? If inner and outer functions have the same monotonicity, whether both increasing or both decreasing, then the composition is always increasing. If inner and outer functions have opposite monotonicity, the composition must be monotonically decreasing, right? So what do we need now? We need the composition to be increasing, but the outer function is decreasing. So we need to find where the inner function is decreasing. Where is the inner function decreasing? Isn't it from 2/3 to positive infinity? So the inner function is monotonically decreasing from 2/3 to positive infinity. This monotonically decreasing interval must intersect with the domain. You can't exceed its domain. So after composition, it's monotonically decreasing interval. So what is y equal to? 4 plus 3x minus x squared over 1. Where is this defined? Just look at the intersection between these intervals. So 2/3 to 4, right? From 2/3 to 4, and you can't use union here. So from 4 to positive infinity, it's monotonically increasing, right? So what's its monotonically increasing interval? That would be from 2/3 to 4. And from 4 to positive infinity. So there are two monotonically increasing intervals. Have you understood this problem?